Let's unit test and write a LERP algorithm. One way I like to test algorithms, if possible, is to write an algorithm different from the algorithm I am testing. And if both of those algorithms get the same result, then I'm feeling good about it. And let me show you here. We have this from the previous video. We have vector A. This is vector A, vector B, like so. And then we have our alpha value here. This is vector A and vector B. Another way to do LERP is to take all of vector A, if you can imagine me stretching this green vector all the way out here, and then I am linearly interpolating, meaning I'm going from 0 to 1 with the alpha. We've seen that before, but 0 to 1 on this red vector. So another way to do LERP is to subtract vector A from vector B, which will give us this red vector, and then scale that red vector by our alpha value. Let me see if I can demonstrate. The original formula we explored in the previous video was 1 minus alpha times vector A, and again alpha is just a number, a scalar, it's Greek, it sounds cool, times alpha, or plus alpha times vector B. That is LERP, but what I've just described here is all of vector A plus alpha times the vector B minus the vector A. Alright, and we could even define LERP to be this instead of this. It doesn't really matter. Maybe one's faster than the other. We could analyze that and profile it, but essentially both of these will get the same result. Always, just geometrically, the second one is taking all of vector A and then an alpha times this difference between vector B and A. So that's the unit test we're going to write and actually implement. We are going to need a source and a target vector. Source vector is the one we're interpolating from, and then the target vector is what we're interpolating to. So let me just punch some numbers in here, and then I think we'll Control L, Control V, target, and just swap these. Actually, let me show off a little bit. Control T, is it? T? Yeah, maybe my showing off isn't going as well as I would like it to. I'm using Control T to transpose the characters here. But now I have a source, I have a target. I want to LERP between these two using the two different algorithms I've shown you thus far and compare the results. So let's set up another vector. Our difference vector, this is going to be the subtraction from the target vector. Target. I'm going to subtract the source from the target, or subtract vector A from vector B, as I showed previously in this video. Float alpha. I want to test various values of alpha. So I think what we'll do is, while alpha is less than or equal to 1, remember alpha can range from 0 to 1. Let's just increment alpha here by a small value 0.1. So we'll test several alphas as we go along. We need two LERP results, vector 3D. LERP result 1 gets LERP. We haven't even stubbed this function out yet, but we will do so quickly. Alpha, I'm going to LERP from source to target using this alpha value. So that will be LERP result 1. And then vector 3D, LERP result 2 will be the source vector, that's all of A as I showed you previously, plus alpha times our difference. Did I call it difference? Vector, oh I forgot my 3Ds up here. Vector 3D, I did an alt drag there to get that to show up. Vector 3D difference. So now I have these two LERP results using two different algorithms. We'll implement this algorithm after we've proven that the tests fail. All we need to do now is expect float equal LERP result 1 dot x is equal to LERP result 2 dot x, and then Control L, Control V, and change this to a y, z, and this one will be a y and a z, and I think that should be good. Let's go over here and make sure engine tester is set as our startup project. Build it, run it, hopefully it builds, and I'm sure we'll get some red if it does build and execute. Of course it doesn't build. I keep doing this. I use functions that I don't even declare. So let's go do that in vector 3D H. Oh, I had them both open already for our convenience, and then I go over to the Solution Explorer and find them anyway. LERP float alpha const vector 3D reference source. Actually, yeah, I don't know. Should we call it A and B or should we call it source? Maybe we'll be consistent with our unit test. Vector 3D reference target, like so. I'm going to control scroll out here a little bit. So there's the declaration of the LERP function. Control Shift L to remove that line. And then down here, let's see, LERP is a non-member right below operator multiplication, so we'll put it right here. No longer need to say inline because we declared it as inline. It's a non-member function as well. I'm considering it to be somewhat of an operator. And then we'll return, Control U, return vector 3D like so. Now we should build, and hopefully we'll get some red when we run this. And I'm seeing a lot of failures fly by the screen because remember we did that loop in there where we were checking various values of alpha. So all that we have left to do now is implement that simple little LERP equation I showed in the previous video. 1 minus alpha times our source plus alpha times our target. Control F5. Hopefully we don't get the screen spam. We don't get any red. All of the tests pass. Feeling good. So now we've implemented LERP in our game. Let's use it, and we'll do it to have a ship path around the screen. It should be a lot of fun.